Today, you will understand how to use scientific notation to express very large and very small quantities. Then you will use this knowledge in real-world applications and simulations. What does all that mean? That means you're going to learn scientific notation. You're going to learn how to write standard to scientific, scientific to standard. And next time, we're going to learn how to apply that to the real world and situations. Very important, you understand what we're doing here because this is a big part of the project. You need to know how to convert standard to scientific, scientific to standard. If not, make sure if you miss something here, watch this lesson online. And then, if that doesn't work, come see me after school for help, okay? All right, first things first, what is scientific notation? Let's figure out what it is. Scientific notation is a compact way of writing numbers that are very large or very small. This is where your pencil goes in your hand. It's a compact way of writing numbers that are very small, very large or very small. So we're going to deal with large numbers, small numbers. We'll get there. Right now, I first want you to understand the parts of scientific notation. When we write something in scientific notation, a lot of the things are the same. We're always going to have a multiplication sign. We're always going to have a base. We're always going to have an exponent. We're always going to have this. First, most important part of scientific notation, this is known as the coefficient. It can be a whole number or a decimal. Does not matter. This is a decimal. It could also be a whole number. It could just be 7. Doesn't matter. What is important is that the coefficient must always be greater than or equal to 1, and it must be less than 10. You cannot have a coefficient of 20. You cannot have a coefficient of 0.4. Quick little reminder here, you cannot have a 0 to the left of the decimal. This is a good coefficient. You don't need to write this, but this, would this be a good coefficient, yes or no?
No.
No, because it is
31.
It's greater than 10. Would this be a good coefficient?
No.
No, because it is less than 1. Would this be a good coefficient? Yes, because greater than or equal to 1. All right. So that's the first part, coefficient, most important part. And of course, multiplication sign. Do me a favor, I know I told you guys not to use X for multiplication. When we write scientific notation, that's probably the only time you can use X. Other than that, use a little dot. Next, what's this called? Anybody? It's 10, but it's called a base. In this concept, it's called a base. And your base will always be 10. It's not going to be 9, 8, 7, 6, 5, 4, 3, 2, 1. Your base will always be 10. And the very last thing, what are these called? Exponents. You're going to have an exponent, and very important, it can be positive, or the exponent can be negative. If it's positive, our coefficient, when written in standard form, will be greater than 1. If it's negative, the exponent, when we write our coefficient in standard form, this coefficient will become less than 1. And that's what we're going to go through today. Right now, just writing the different parts. You might see the same diagram on a quiz, and I might have you label the parts. Make sure you understand that this is a coefficient. You should definitely know what this is, right? If not, then I don't know how you got the 8th grade or 7th grade. That's a base, that's a exponent. Keep this diagram in mind for your quiz. You need to know everything. I might even ask you a question, is 31 a good coefficient? Yes or no? You need to explain why. I'm all about the explanations. Right now, let's do the first example. This number is 143,000. This is known as standard form right here. That's the way you've been writing numbers up to this point. You've been writing numbers like 1.3 or 2.4, 143,000, 5,623,412, which is money I wish I had in my pocket, but I don't. 142,000. I'd even take that. I would take that. I put that in my pocket and I call it a day. But I don't have that. That's not the point. What we're going to do with this is we are going to turn this into scientific notation. Do you see a decimal here, yes or no? No, but I do see a comma. But we don't need a comma, I need a decimal. So let's figure out where this decimal is. I'm going to write this number, 143,000. We got to see if there's a decimal there. Is there an invisible decimal there somewhere? Hold on, let's go to Sidney Cassidy. Is there an invisible decimal point there? Where is it?
In between next to the 1.
Here?
I know, the other side.
All the way over here, right? Yeah. Isn't this number the same as this number? Yes. So technically, every number has an invisible decimal point right at the end of the number. That's if it doesn't already have a decimal point, like this one or this one. We're not worrying about this right now. We're back here. All right, so I need to turn this into scientific notation. first thing I need to do is I need to turn this number into a proper coefficient. Remember, a coefficient has to be greater than or equal to 1, and it has to be less than 10. So I'm going to move the decimal, and you guys tell me if you think I should stop. Should I stop here?
No.
No. Should I stop here?
No.
Right here, though, right?
No.
And we got it, right?
No.
One more? Right here? We sure?
Yeah.
You sure shouldn't go on to the next one?
No.
Okay, well, let's see. If I drop it here, if I drop the decimal here, I'm going to have 1.43. Let's see if it satisfies our criteria. Is that number greater than or equal to 1? Yes or no?
Yes.
Yeah. Bingo! Is that less than 10?
Yes.
Yes, I do declare that as good factor. Hallelujah. Amen. Wait till you show your parents that on the video, right? All right, that's the first part, coefficient. What comes immediately after the coefficient? Shman? What comes immediately after the coefficient? It's the first letter of your first name, dude. What is it? X. Yes, everyone knows that. Multiplication sign comes immediately after the coefficient. There you go. And then, Rachel, Thomas? Rachel? What comes after the multiplication sign? 10. What is 10 called again? 10 is the base. Yeah, we put the base. Is the base ever going to be a number besides 10?
No.
No, base will always be 10. Bingo. Okay. I need one final thing here to go load up. What do I need? Well, not the answer. I need the starts with an E, then an X, then a P.
The exponent.
Yeah, I need the exponent. Okay, so I need the exponent. Just Miguel. Miguel, I need an exponent. But am I just going to create an exponent out of thin air and be like, hello, thin air? Fine! Put it on the board. No. We need to figure out mathematically how to get an exponent. How do you think, just him, man. How do you think we get the exponent here? What do we do? How did you generate an exponent from what we just did from here? How did you get an exponent there? What did you do?
You move the decimal.
Well, count. There we go. How many times did you move this decimal? How many times?
5.
I moved 5 times. Now hold on before you write this. I moved it 5 times. But remember, I said that exponents could be negative or positive. There's 2 ways that you'll know if the exponent is going to be positive. First way, look at the original number. Is this number greater than 1? Yes. That's the first way to tell that your exponent is going to be positive. There's another way, kind of an easier way. Which way did we move the decimal here?
That way.
To the left. If you move your decimal to the left, I even wrote it right here. If you move your decimal to the left, the exponent is going to be positive. So when you move to the left, your exponent is positive. Miguel, finish it up for me. What number goes there?
5.
You sure? Sure it's not 6?
I'm pretty sure it's 5.
You 100%?
Yeah, I'm 100%.
Would you bet your life on it?
I would bet.
Okay, yes, good. Good job. Ding, 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 yeah, it's 5. 1.43 times 10 to the 5th is 142,000 expressed in scientific notation. And the reason that makes sense is because if we did 10 to the 5th power, anybody know what 10 to the 5th power is, just off the top of their heads? Flash, what is it? Anybody? What is it? 10 to the 5th power? No, we're doing 10 times 10 is 100. 100 times 10 is 1,000. 1,000 times 10 is 10,000, and then it would be? No, it would be a million. It would be 100,000. And that makes sense, because if we multiplied 1.43 times 100,000, what would we get? 143,000. That's why this makes sense. That's how you put a number into scientific notation. We see if we have all the parts. Coefficient, good. Multiplication sign, good. Base is 10, good. Exponent, 1, 2, 3, 4, 5. We move to the left, it's positive. That's how we do it. Let's run through some more. Let's pick on, Corey's not here. And Nolasco. We'll call you No Name Nolasco now. You put no name on that test. No Name Nolasco. All right, no name. We want to turn this number, not this number, this number, into scientific notation. So I'm going to write the number. That's the first step. Write the number. And then you ask yourself, you say, hey, self, where is a decimal point? Do you see one up there? Is there a decimal point right here right now?
Yes.
There's a decimal point?
Well, no, but
But where is it? Where's the invisible decimal point?
right next to the 0.
Right next to the 0. Right here. Okay. What's the next thing you're going to do, No Name?
You're gonna move it
Which way? to the left, okay? And then the last go, tell me, am I gonna stop here? Am I gonna stop here?
No.
Am I gonna stop here?
No.
What about here?
No.
That looks pretty good though, right?
No.
Here?
Yes.
Okay, we're gonna stop here. And the last go, why did you stop there?
Because it's more than 1, but it's less than 10.
Yes! 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 Because this number is 2.5675. Greater than 1? Yes. Greater than or equal to 1? Yes. Less than 10? Good. Coefficient. What comes after my coefficient? Just no last go.
The multiplication.
Bingo. And then
10.
the base, which is 10. And then, just heard some of you like, I know the answer. I'm going to blurt it out to ruin it for. What's your exponent going to be?
5.
1, 2, 3, 4, 5. Good job. My exponent's 5. Good job. I'll give you a ticket. Good job. Good job. Money bags. Fiamma Ferreira with them golden scissors. Scissors plated in like 49 karat gold and stuff. Like, my scissors are worth more than your car. All right. Fiamma. Fiamma. We have 312. Why is there this? Nobody pointed out the error. That should definitely not be there. All right, we have 312.5. Fiamma, this time you have the decimal point. Yeah, you just scratch it out. This time you have a decimal point, right? Okay, so you're going to start with the decimal point. Which way are you moving? To the left, okay? We're moving to the left. How many times? 2 times. Let's see. Uno y dos. We put it right there. Sure.
It's more than 1, but it's less than 10.
Let's see. Is this more than 1? 3.125? Yeah, it's more than 1. It's less than 10. It's good. It's good. So good! All right, what comes after the coefficient?
10. I mean, the x of the multiplier.
The multiplication sign, yes, I know my 5s look like S's. It's not 3.12S. And that's a 10. And then, what is your exponent, yeah? It's 2. Are you sure it's not 3? True. Look at you second guessing yourself. All right, yeah, it's 2. Good job. True. Fiamma. Fiamma. Slam. Yes, you have a question?
You said that it could.
I said that it could be what?
Oh,
Did you answer your own question?
I think I did.
Okay. I said that it had to be greater than or equal to 1. You're talking about this?
No,
What are you talking about this?
I'm talking about the negative and positive.
I was just thinking about
The negative and positive?
Yeah.
We moved to the left, right? We moved the decimal to the left, correct? Didn't we move this decimal to the left? And when you move to the decimal to the left, the exponent is going to be positive. The other way to tell if the exponent is going to be positive, look at the original number. Is that greater than 1? Yes, therefore, exponent positive. This number, is it greater than 1?
Yes.
Therefore, exponent's going to be positive. You positive it's positive? Yeah, you're positive it's positive. No, I'm negative it's positive.
Then how about for that one? You can't move anything to the left.
You tell me.
I can't
Well,
tell you. I don't know.
first of all, let's ask ourselves a question. Is this coefficient already good?
Yes.
It's already good. Okay, so let's write it. 6.00001. We still write this in scientific notation. Matthew, what comes after the coefficient?
Wait, the decimal? Coefficient.
What comes after the coefficient?
I don't know.
Look at the previous example. Coefficient, what comes after?
Oh, the x? Well, wait,
X.
what about that?
What about
We
what?
already did that.
What
It's
do you mean
already
we did this
coefficient.
one? We already did this one. We're here.
I know, but wait, but how'd you go from this one and then skip the equal sign and then go to this? The x.
Because the coefficient was already good. Did I have to move the decimal?
Oh my god.
Oh, snap.
Oh, so it's gonna be 10.
So I didn't have to move the decimal.
I didn't know.
But now you know. The more you know. All right.
So then times 10.
Times 10. But hold on.
But then you didn't move.
If I were to multiply this times 10, that would make this 60.0001. Can't have that. So the only thing I can multiply this by is 1. What's my exponent going to be?
0.
0. Because anything to the 0 power is always 1. And of course that makes sense because if you don't move something, Matthew, you're in your car, you got no gas, you driving anywhere? No, you didn't go anywhere, right? You didn't back up, you didn't go forward, you went 0 miles. Therefore, that's your exponent.
I was right.
That's 1, right?
6.0001 times 10 to the 0 power. Yes.
When would you go? When would it be a negative?
We're going to get to that. That's going to be the next thing we do.
Oh,
We're going to get to the negatives when we have a number that is less than 1. Is this less than 1? Is that less than 1? Is that less than 1? These are all positive. We're going to do the negatives.
Am I not good enough for 50?
When rewriting, the coefficient will always have to be more than 1, but my exponent can be negative. You'll see when we get there. You're going ahead, don't worry. I'll get there. We're on a journey. It's like I'm taking you on a journey. Let's go! The land of scientific notation. You're like, no, I don't want to go. What's up? Because we're writing it in scientific notation, right? He wants to know why I have to put the 0. I'm writing in scientific notation. Therefore, I need a coefficient. I need my multiplication sign. I need a base. I need an exponent. I have to have an exponent. If I don't write 0, then I'm saying that I'm doing 6.00001 times 10, which would make this, when we multiply this by 10, it would turn this into 60, which is not the same number as this, is it? I have to keep it. Even though I change this to scientific notation, and I change this, and I change this, it's still the same number. If I were to multiply out these 10s, I would get the exact same number that I had here. Exact same number that I had here. The reason I make this 0 is because anything to the 0 power is 1. If I were to multiply this number by 1, would that change it? No. Therefore, that's the only exponent that I can have that would keep this number the same. ¿Verdad? ¿Verdad? I don't even know if that's real Spanish. I think I just made that up. All right. 4, 3, 2, 1, por favor. Grab un bolo blanco and put a number on and let me know how you think that went. That's my Spanish word of the day. El gordo blanco. What does that mean? He doesn't speak Spanish at all, does he?
The fat guy.
The fat guy?
White guy.
The fat white guy? No, isn't that like, El gordo blanquito cracker? Alright, 4, 3, 2, 1. Okay, okay. I need boards. Boards in the sky. Boards in the sky. Okay. Here's what you're doing. Split your board. Split your board. Shh. What's up? You don't have a board? Why don't you have a board?
Well, I do.
Come on. You have a. Look, oh my god, it's so much faster. And you're done. Alright. Viviana. The second. Madison. Where's your notes? Go back up. Go on. Madison. Thank you. Viviana, you were asking, where's the negatives? You said positive, negative. Here's the negatives. Here's 1. Look at this number right here. Let me ask you a question. Is this number greater than or less than 1? Less than 1. Plus, when we have to turn this coefficient into a proper coefficient, we move the decimal. Which way are we moving the decimal this time? Right. So if we look at this first example, we're going to move the decimal.
Then the answer would be a negative.
You'll see, yes. We're going to move the decimal 1, 2, 3, 4 times to the right. And it's going to be 4.14. We have a good coefficient now. We do. It's greater than or equal to 1. It's less than 10. We write our multiplication sign. We write our base. Our base is always 10. And then our exponent. Because we moved to the right, my exponent's going to be negative. Or if that doesn't work for you, just think about it. This number, the original number, was less than 1. Whenever you see a number that's less than 1 and you're putting it into scientific notation, your exponent will always be negative. So what's my exponent going to be here? Brianna?
Me.
Negative 4. I count. 1, 2, 3, 4. It's negative 4. As you can see, the first part was probably the most difficult. Once you get the idea, it's the same thing over and over and over, just using different forms of it. Oh, actually, that was on your desk. All right. Okay. Yes, Matthew?
Can I do the next one?
If it's your turn on the cards, but that way everyone gets a fair shot. I know, because I'll just end up usually calling the same people. That's why this is fair. Madison, we want to turn this into proper scientific notation. Madison, what do you do?
Well, you have to move the decimal to the right once.
One time. Okay, so we move the decimal here, and this is going to be 3.13. Then what comes after that? Times. Okay. 10. What's your exponent?
Negative 1.
Negative 1.
No, negative 0.
Is there such a thing as negative 0? It's negative 0. It's so different than positive 0. It's totally different numbers. You probably thought you were wrong because I was like, negative 1? No, you're right. It's negative 1.
Oh.
Believe in yourself, child. Yes, you're right. It's negative 1. She was scared for a second. She's like, what? What do you mean? I'm understanding nothing. Okay. I'll give you a tip in a second. And let's see what we got here. Jennifer Gutierrez. Jennifer Gutierrez. Sorry, Calco. You had a question, buddy. Calco, you had a question?
No.
Oh, you just want to do the next one? Yeah, I know. We'll get around to you, man. Everyone gets a fair shot on the
I
cards.
haven't gotten like
For
I shuffle up, it's the odds, man. Sometimes you'll go more than less. Jennifer, GTR, where you at? Right there? Alright, Jennifer. Which way am I moving the decimal?
To the right.
To the right? How many times?
4 times.
Let's see. 1, 2, 3, and 4. We drop it. Okay, looks good to me. Is this coefficient greater than or equal to 1?
Yes.
Yes. Is it less than 10?
Yes.
Yes. So it's a good coefficient. What comes after that, Jennifer?
You times it.
Times, okay.
10.
10, and what's my exponent going to be?
4. Negative 4.
Okay. Good job. Lucas!
Yep.
Not to be confused with George Lucas, creator of Star Wars. Lucas Perdomo.
Yeah.
Woo! That's a lot of zeros. Woo! I haven't seen that many zeros since I looked at my checking account. And I just see only zeros. Alright, Lucas, which way are you moving the decimal?
To the right.
To the right. How many times?
11.
Let's see. 1, 2, count with me. 3,
4,
5, 6, 7, 8, 9, 10, 11. That works. And you can write this as.
1.0.
But do I need the point 0?
No.
No, I can just write it as 1. Remember, on the very first slide, it said that the coefficient can be a decimal or a whole number. In this case, it'll be a whole number. Now I'm going to write 1 times. What's my base, Lucas?
10.
10. You sure it's not going to be 11?
No. Sure.
Okay, then what's my exponent?
Negative 11.
Negative. You sure it's not negative 12?
No.
Why is it negative 11?
It is negative 11.
But why? Tell me why.
Because we moved to the right.
Move to the right, okay. And because the original number was
1.
less than 1. So it's going to be 11 because we moved it 11 times, and it's going to be negative because we moved to the right. It was less than 1. Questions on this?
No.
So yeah, this is easy. The next 2 parts are easier because you're getting more and more practice with it. Now, as you can see, the first couple things we did standard to scientific. Once we do the whiteboard here, we're just going to be reversing. We're doing scientific to standard. We just reverse out the process. Questions, 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 questions. Yes? Okay, what you're doing, Shimon, is, let's have a number here, right? Well, let's say we have 0.000375. What you're doing is you're looking to move this decimal until you satisfy this criteria. You need to have a number that is greater than or equal to 1. You with me? And that number also must be less than 10. So we're going to move this decimal. If I move it here and I stop, now my number is 0.00375. Is that greater than 1? No. So let's move it again. Now I'll have 0.0375. Is that greater than 1? No. So let's move it again. When I move it there, now I have 0.375. Is that greater than 1? Nope. So I move it one more time, and I drop it there, and I'm going to get 3.75. Is that greater than 1? Is it less than 10? Yes. That's when you stop. Once you find the decimal point, the decimal place where it'll be greater than or equal to 1 or less than 10, you can stop right there. And then that becomes your coefficient. You write your multiplication, you write your base, and then you look. Okay, I move to the right. So that means that my exponent is going to be, okay, negative. It's going to be negative. And I moved it 1, 2, 3, 4 times, so it's going to be negative 4. The other way you could tell that the decimal is going to be negative, if we look at our original number here, this number right here, is that number greater than 1? No. If it's less than 1, if the number is less than 1, then your exponent is going to be negative. If your number is greater than or equal to 1, then your exponent is going to be positive. Okay? That's the other way to remember. Whatever way works for you, I'm all about you learning multiple ways for me to teach. Okay. Was that a sneeze? Like a happy, it's like,
Money comes out of her nose when she sneezes.
That'd be great. Like, how's your 100? Benjamin, hold on. Make it rain. No, that joke didn't work for you. That's the joke that didn't work for you. Okay. 4, 3, 2, 1. Cuatro, tres, dos, uno. El something Pizarro. Francisco Pizarro. There we go. That joke? No. Oh, no. That's gonna be like. And 4, 3, 2, 1. All right. All right. like what I'm seeing. I like what I'm seeing.
What is that?
It's very artistic. All right. Turn them all into scientific notation, please.